U.S. higher education is facing a structural crisis. Enrollments in traditional brick-and-mortar institutions continue to decline, while the cost of tuition climbs higher every year. The financial model that sustained universities for decades is crumbling under the pressure. At the same time, the typical college student profile has changed. The new majority of post-secondary enrollment is made up of non-traditional learners. These are students aged 25 or older, balancing full-time jobs, family obligations, and heavy technological integration into their daily lives. Because of these life constraints, these working adults approach education with strict requirements. They demand flexible online delivery, direct relevance to their industry, and an immediate return on their tuition investment through highly functional workplace skills. Recognizing this shift, institutions panicked. To capture these students and secure their tuition dollars, universities rapidly migrated their existing heavily content-based instruction into digital formats. To execute this migration quickly, administrators relied almost exclusively on the Learning Management System, or LMS. The goal was speed and scale, turning these systems into central repositories for course materials. Using a digital learning environment as a storage locker for physical content replicates the passive nature of a lecture hall on a screen. This approach degrades the degree's value by prioritizing institutional administration over the needs of the learner. This default LMS environment operates like a vacuum. It is a rigid architectural space optimized for tracking, file folders, and menus, systematically boxing in the learner. This restricts instructional design. The system imposes a passive, one-size-fits-all pedagogy onto every student, regardless of subject matter. The necessary antidote to this rigid environment is Learner Experience Design, or LXD. LXD adapts principles from user experience design, a discipline forged in Silicon Valley to study and improve human interaction with complex computer systems. Where user experience design examines the holistic, effective behaviors of a person navigating a digital product, the default LMS focuses on the institution's need to distribute content. One optimizes for human behavior, the other optimizes for file management. To survive the current educational crisis, institutions must abandon this content-centric approach. They must engineer digital environments that treat learning as a holistic human-computer interaction. The first obstacle to engineering better interactions is a psychological bias known as functional fixedness. This is the cognitive compulsion to use a tool only in the standard, predetermined way its developers intended. If a software template provides a slot for a PDF reading and a multiple-choice quiz, the designer instinctively builds a course consisting only of readings and quizzes. Traditional instructional design models exacerbate this bias. The process is often highly insular, relying entirely on a solitary subject matter expert to make all structural decisions without testing the interface. This creates an inside-out methodology. The subject matter expert focuses entirely on what raw information needs to be injected into the software, rather than how a human will actually navigate and internalize that information. This inside-out method rests on a dangerous assumption, the belief that learning is a purely cognitive task of transferring data from an expert's brain into a digital folder and finally into a student's memory. Because of this assumption, we end up with functionally perfect online courses that consistently fail. They fail because their architecture satisfies the structural needs of the software, entirely ignoring the psychological reality of the learner. This diagram illustrates the reality of how humans actually process new information. Learning is an integrated process of holistic human adaptation that spans 4 distinct dimensions. First is the cognitive dimension. This encompasses the baseline mental processes we usually associate with studying: perception, memory, reasoning, and knowledge construction. Traditional LMS instructional design over-indexes almost entirely on this single pillar, treating it as the only metric of success. Second is the behavioral dimension. This bridges the knowing-doing gap. It involves how learners self-regulate their time, make choices within the interface, and physically apply the knowledge they've constructed. Third is the social dimension. Meaningful adaptation requires discourse. This dimension maps the relationships, collaborative friction, and peer-to-peer interactions that occur within the digital space. Finally, the emotional dimension. This is the psychodynamic state of the learner, the positive and negative emotions that dictate their motivation and deep engagement with the material. Impactful learner experience design requires architectural attention to be distributed across all 4 dimensions to facilitate true adaptation. The emotional dimension is the most frequently misunderstood. In professional design circles, there is a misconception that designing for emotion simply means making the digital experience enjoyable. The psychological reality of deep learning is quite different. When a user is confronted with highly complex, novel material, the process is inherently uncomfortable. A properly designed course must carefully manage episodes of learner confusion, anxiety, and intellectual struggle. The goal is not to eliminate friction, but to calibrate it. These specific negative emotional states are biologically required. Without a period of struggle and confusion, a learner cannot reach the subsequent positive states of flow, delight, and true accomplishment. LXD prioritizes deep psychological engagement over the superficial ease of frictionless UI navigation. Effective learning ecosystems must be engineered to support this productive frustration. To shatter the bias of functional fixedness and implement these 4 dimensions, institutions need a new mechanical tool: participatory design. Unlike the solitary subject matter expert model, participatory design demands continuous feedback from multiple stakeholders, most importantly, the prospective learners themselves, long before a course is launched. This feedback relies on the formalized design thinking loop, the engine that powers effective learner experience design. The loop begins by shifting to an outside-in perspective. Designers must explicitly map the life constraints, technological reality, and specific needs of the end user. Next, the design team forces the course architecture past the first obvious, software-dictated solution. They brainstorm structural alternatives that address the user's mapped constraints. Finally, those alternatives undergo rapid iteration. Designers collect feed-forward, testing rough mock-ups with actual learners to vet the architecture before a single piece of content is permanently locked in. Adopting this cyclical process reverses the traditional power dynamic of the software. It ensures the digital environment adapts to the human, rather than forcing the human to adapt to the limitations of the LMS. The required architectural change is clear. The psychodynamics of the learner must sit at the exact center of the design process, pushing the technology interface into the background. Learning experiences are never accidental. They are deliberately designed states resulting from a vast sequence of structural choices. Every single module, every new assignment, and every subtle user interface choice is an active architectural decision that either supports or degrades the 4 dimensions of learning. When executed correctly, the rigid filing cabinet of the traditional LMS dissolves entirely into a dynamic, multidimensional learning ecosystem. Institutions that continue to rely on standard, content-centric delivery risk losing relevance to a tech-savvy demographic that requires a high-functioning, multidimensional return on investment.